In this video, I'm going to share an interesting data analytics case study. It will illustrate how problem solving relates to each phase of the data analysis process and shed some light on how these phases work in the real world. It's about a small business that used data to solve a unique problem it was facing. The business is called Anywhere Gaming Repair. It's a service provider that comes to you to fix your broken video game systems or accessories. The owner wanted to expand his business. He knew advertising is a proven way to get more customers, but he wasn't sure where to start. There are all kinds of different advertising strategies, including print, billboard, TV commercials, public transportation, podcasts, and radio. One of the key things to think about when choosing an advertising method is your target audience. In other words, the specific people you're trying to reach. For example, if a medical equipment manufacturer wanted to reach doctors, placing an ad in a health magazine would be a smart choice. Or, if a catering company wanted to find new cooks, it might advertise using a poster at a bus stop near a cooking school. Both of these are great ways to get your ad seen by your target audience. The second thing to think about is your budget and how much the different advertising methods will cost. For instance, a TV ad is likely to be more expensive than a radio ad. A large billboard will probably cost more than a small poster on the back of a city bus. The business owner asked the data analyst, Maria, to make a recommendation. She started with the first step in the data analysis process, ask. Maria began by defining the problem that needed to be solved. To do this, she first had to zoom out and look at the whole situation in context. That way, she could be sure that she was focusing on the real problem and not just its symptoms. This leads us to another important part of the problem-solving process, collaborating with stakeholders and understanding their needs. For Anywhere Gaming Repair, stakeholders included the owner, the vice president of communications, and the director of marketing and finance. Working together, Maria and the stakeholders agreed on the problem, not knowing their target audience's preferred type of advertising. Next up was the prepare phase, where Maria collected data for the upcoming analysis process. But first, she needed to better understand the company's target audience, people with video game systems. After that, Maria collected data on the different advertising methods. This way, she would be able to determine which was the most popular one with the company's target audience. Then, she moved on to the process step. Here, Maria cleaned the data to eliminate any errors or inaccuracies that could get in the way of the result. As we've learned, when you clean data, you transform it into a more useful format, create more complete information, and remove outliers. Then, it was time to analyze. In this step, Maria wanted to find out two things. First, who's most likely to own a video gaming system? And second, where are these people most likely to see an advertisement? Maria first discovered that people between the ages of 18 and 34 are most likely to make video game related purchases. So, she could confirm that Anywhere Gaming Repair's target audience was people 18 to 34 years old. This was who they should be trying to reach. With this in mind, Maria then learned that both TV commercials and podcasts are very popular with people in the target audience. Because Maria knew Anywhere Gaming Repair had a limited budget and understanding the high cost of TV commercials, her recommendation was to advertise in podcasts because they are more cost effective. Now that she had her analysis, it was time for Maria to share her recommendation so the company could make a data-driven decision. She summarized her results using clear and compelling visuals of the analysis. This helped her stakeholders understand the solution to the original problem. Finally, Anywhere Gaming Repair took action. They worked with a local podcast production agency to create a 30-second ad about their services. The ad ran on podcast for a month, and it worked. They saw an increase in customers after just the first week. By the end of week 4, they had 85 new customers. There you go, effective problem solving using data analysis phases in action. Now you've seen how the 6 phases of data analysis can be applied to problem solving and how you can use that to solve real-world problems. Six phases of data analysis can be applied to problem solving and how you can use that to solve real-world problems.
I'm Nikki, and I manage the Education, Evaluation, Assessment, and Research team. My favorite part of the data analysis process is finding the hardest problem and asking a million questions about it and seeing if it's even possible to get an answer. So one of the problems that we've tackled here at Google is our nuclear onboarding program, which is how we onboard new hires. One of the things that we've done is ask the question, how do we know whether or not newglers are onboarding faster through our new onboarding program than our old onboarding program, where we used to lecture them? And we worked really closely with the content providers to understand just exactly what does it mean to onboard someone faster. Once we asked all the questions, what we did is we prepared the data by understanding who was the population of the new hires that we were examining. So we prepared our data by going through and understanding who our populations were, by understanding who our sample set was, who our control group was, who our experiment group was, where were our data sources, and make sure that it was in a format that was clean and digestible for us to write the proper scripts for. So the next step for us was to process the data to make sure that it was in a format that we could actually analyze in SQL, making sure that it was in the right format and in the right columns and in the right tables for us. To analyze the data, we wrote scripts in SQL and in R to correlate the data to the control group or the experiment group and interpret the data to understand, were there any changes in the behavioral indicators that we saw? Once we analyze all the data, we want to report on it in a way that our stakeholders could understand. So depending on who our stakeholders were, we prepared reports, dashboards, and presentations and share that information out. Once all of our reports were complete, we saw really positive results and decided to act on it by continuing our project-based learning onboarding program. It was really satisfying to know that we had the data to support it and that it really, really worked. And not just that the data was there, but that we knew that our students were learning and that they were more productive faster back on their jobs.
In a previous video, I shared how data analysis helped a company figure out where to advertise its services. An important part of this process was strong problem-solving skills. As a data analyst, you'll find that problems are at the center of what you do every single day. But that's a good thing. Think of problems as opportunities to put your skills to work and find creative and insightful solutions. Problems can be small or large, simple or complex. No problem is like another, and they all require a slightly different approach. But the first step is always the same: understanding what kind of problem you're trying to solve. And that's what we're going to talk about now. Data analysts work with a variety of problems. In this video, we're going to focus on 6 common types. These include making predictions, categorizing things, spotting something unusual, identifying themes, discovering connections, and finding patterns. Let's define each of these now. First, making predictions. This problem type involves using data to make an informed decision about how things may be in the future. For example, a hospital system might use a remote patient monitoring to predict health events for chronically ill patients. The patients would take their health vitals at home every day, and that information, combined with data about their age, risk factors, and other important details, could enable the hospital's algorithm to predict future health problems and even reduce future hospitalizations. The next problem type is categorizing things. This means assigning information to different groups or clusters based on common features. An example of this problem type is a manufacturer that reviews data on shop floor employee performance. An analyst might create a group for employees who are most and least effective at engineering, a group for employees who are most and least effective at repair and maintenance, most and least effective at assembly, and many more groups or clusters. Next, we have spotting something unusual. In this problem type, data analysts identify data that is different from the norm. An instance of spotting something unusual in the real world is a school system that has a sudden increase in the number of students registered, maybe as big as a 30% jump in the number of students. A data analyst might look into this upswing and discover that several new apartment complexes had been built in the school district earlier that year. They could use this analysis to make sure the school has enough resources to handle the additional students. Identifying themes is the next problem type. Identifying themes takes categorization as a step further by grouping information into broader concepts. So, going back to our manufacturer that has just reviewed data on the shop floor employees, first, these people were grouped by types and tasks. But now, a data analyst could take those categories and group them into the broader concept of low productivity and high productivity. This would make it possible for the business to see who is most and least productive in order to reward top performers, and provide additional support to those workers who need more training. Now, the problem type of discovering connections enables data analysts to find similar challenges faced by different entities, and then combine data and insights to address them. Here's what I mean. Say a scooter company is experiencing an issue with the wheels it gets from its wheel supplier. The company would have to stop production until it could get safe, quality wheels back in stock. But meanwhile, the wheel company is encountering the problem with the rubber it uses to make wheels. Turns out, its rubber supplier could not find the right materials either. If all of these entities could talk about the problems they're facing and share data openly, they would find a lot of similar challenges, and better yet, be able to collaborate to find a solution. The final problem type is finding patterns. Data analysts use data to find patterns by using historical data to understand what happened in the past and is therefore likely to happen again. E-commerce companies use data to find patterns all the time. Data analysts look at transaction data to understand customer buying habits at certain points in time throughout the year. They may find that customers buy more canned goods right before a hurricane, or they purchase fewer cold weather accessories like hats and gloves during warmer months. The e-commerce companies can use these insights to make sure they stock the right amounts of products at these key times. Alright, you've now learned 6 basic problem types that data analysts typically face. As a future data analyst, this is going to be valuable knowledge for your career. Coming up, we'll talk a bit more about these problem types, and I'll provide even more examples of them being solved by data analysts. Personally, I love real-world examples. They really helped me better understand new concepts. So I can't wait to share even more actual cases with you. See you there. You've been learning about 6 common problem types that data analysts encounter: making predictions, categorizing things, spotting something unusual, identifying themes, discovering connections, and finding patterns. Let's think back to our real-world example from a previous video. In that example, Anywhere Gaming Repair wanted to figure out how to bring in new customers. So the problem was how to determine the best advertising method for Anywhere Gaming Repair's target audience. To help solve this problem, the company used data to envision what would happen if it advertised in different places. Now, nobody can see the future, but the data helped them make an informed decision about how things would likely work out. So, their problem type was making predictions. Now, let's think about the second problem type, categorizing things. Here's an example of a problem that involves categorization. Let's say a business wants to improve its customer satisfaction levels. Data analysts could review recorded calls to the company's customer service department and evaluate the satisfaction levels of each caller. They could identify certain keywords or phrases that come up during the phone calls and then assign them to categories such as politeness, satisfaction, dissatisfaction, empathy, and more. Categorizing these keywords gives us data that lets the company identify top-performing customer service representatives and those who might need more coaching. This leads to happier customers and higher customer service scores. Okay, now let's talk about a problem that involves spotting something unusual. Some of you may have a smartwatch. My favorite app is for health tracking. These apps can help people stay healthy by collecting data such as their heart rate, sleep patterns, exercise routine, and much more. There are many stories out there about health apps actually saving people's lives. One is about a woman who was young, athletic, and had no previous medical problems. One night, she heard a beep on her smartwatch. A notification said her heart rate had spiked. Now, in this example, think of the watch as a data analyst. The watch was collecting and analyzing health data. So, when her resting heart rate was suddenly 120 beats per minute, the watch spotted something unusual because according to its data, the rate was normally around 70. Thanks to the data her smartwatch gave her, the woman went to the hospital and discovered she had a condition which could have led to life-threatening complications if she hadn't gotten medical help. Now let's move on to the next type of problem, identifying themes. We see a lot of examples of this in the user experience field. User experience designers study and work to improve the interactions people have with products they use every day. Let's say a user experience designer wants to see what customers think about the coffee maker his company manufactures. This business collects anonymous survey data from users, which can be used to answer this question. But first, to make sense of it all, he will need to find themes that represent the most valuable data, especially information he can use to make the user experience even better. So, the problem the user experience designer's company faces is how to improve the user experience for its coffee makers. The process here is kind of like finding categories for keywords and phrases in customer service conversations. But identifying themes goes even further by grouping each insight into a broader theme. Then, the designer can pinpoint the themes that are most common. In this case, he learned users often couldn't tell if the coffee maker was on or off. He ended up optimizing the design with improved placement and lighting for the on-off button, leading to the product improvement and happier users. Now we come to the problem of discovering connections. This example is from the transportation industry and uses something called third-party logistics. Third-party logistics partners help businesses ship products when they don't have their own trucks, planes, or ships. A common problem these partners face is figuring out how to reduce wait time. Wait time happens when a truck driver from the third-party logistics provider arrives to pick up a shipment, but it's not ready, so she has to wait. That costs both companies time and money, and it stops trucks from getting back on the road to make more deliveries. So how can they solve this? Well, by sharing data, the partner companies can view each other's timelines and see what's causing shipments to run late. Then they can figure out how to avoid those problems in the future, so a problem for one business doesn't cause a negative impact for the other. For example, if shipments are running late because one company only delivers Mondays, Wednesdays, and Fridays, and the other company only delivers Tuesdays and Thursdays, then the companies can choose to deliver on the same day to reduce wait time for customers. All right, we've come to our final problem type, finding patterns. Oil and gas companies are constantly working to keep their machines running properly. So the problem is how to stop machines from breaking down. One way data analysts can do this is by looking at patterns in the company's historical data. For example, they could investigate how and when a particular machine broke down in the past and then generate insights into what led to the breakage. In this case, the company saw a pattern indicating that machines began breaking down at faster rates when maintenance wasn't kept up in 15-day cycles. They can then keep track of current conditions and intervene if any of these issues happen again. Pretty cool, right? I'm always amazed to hear about how data helps real people and businesses make meaningful change. I hope you are too. See you soon.
Hi, I'm Anmol. I'm the head of large advertiser marketing analytics within the marketing team at Google. So at its core, my job is about connecting the right user with the right message at the right time. The first step is really to get a broad sense of a certain pattern that's occurring. So, for example, we know that this particular segment of users is more responsive to this type of content. Once we're able to actually see this hypothesis through the data, we do testing to ensure that the hypothesis is actually correct. So, for example, we would test sending these pieces of content to this segment of users and actually verify within a controlled environment whether that response rate is actually higher for that type of content or whether it isn't. And so once we're able to actually verify that hypothesis, we go back to the stakeholders, in this case, our marketers, and say, we've actually proven within a relatively high degree of certainty that this particular segment is more responsive to this type of content. And because of that, we're recommending that you produce more of this type of content. And so our stakeholders really get to see the whole sort of evolution from hypothesis to proven concept. And they're able to come with us on the journey on how we're proving out these hypotheses and then eventually turning them into strategies and recommendations for the business. So the outcome in this case was that we were able to actually change the way our whole marketing team worked to actually make it much more user-centric. So instead of, from our perspective, coming up with content that we think the users need, we're actually going in the other direction of figuring out what users need first, proving that they need certain things or they don't need certain things, and then using that information going back to marketers and coming up with content that fulfills their need. So it really changed the direction of how we produce things.
Now that we've talked about 6 basic problem types, it's time to start solving them. To do that, data analysts start by asking the right questions. In this video, we're going to learn how to ask effective questions that lead to key insights you can use to solve all kinds of problems. As a data analyst, I ask questions constantly. It's a huge part of the job. If someone requests that I work on a project, I ask questions to make sure we're on the same page about the plan and the goals. And when I do get a result, I question it. Is the data showing me something superficially? Is there a conflict somewhere that needs to be resolved? The more questions you ask, the more you'll learn about your data and the more powerful your insights will be at the end of the day. Some questions are more effective than others. Let's say you're having lunch with a friend and they say, "These are the best sandwiches ever, aren't they?" Well, that question doesn't really give you the opportunity to share your own opinion, especially if you happen to disagree and didn't enjoy the sandwich very much. This is called a leading question because it's leading you to answer in a certain way. Or maybe you're working on a project and you decide to interview a family member. Say you ask your uncle, "Did you enjoy growing up in Malaysia?" He may reply, "Yes," but you haven't learned much about his experiences there. Your question was closed-ended. That means it can be answered with a yes or no. These kinds of questions rarely lead to valuable insights. Now, what if someone asks you, "Do you prefer chocolate or vanilla?" Well, what are they specifically talking about? Ice cream, pudding, coffee flavoring, or something else? What if you like chocolate ice cream but vanilla in your coffee? What if you don't like either flavor? That's the problem with this question. It's too vague and lacks context. Knowing the difference between effective and ineffective questions is essential for your future career as a data analyst. After all, the data analyst process starts with the ask phase. So it's important that we ask the right questions. Effective questions follow the SMART methodology. That means they're specific, measurable, action-oriented, relevant, and time-bound. Let's break that down. Specific questions are simple, significant, and focused on a single topic or a few closely related ideas. This helps us collect information that's relevant to what we're investigating. If a question is too general, try to narrow it down by focusing on just one element. For example, instead of asking a closed-ended question like, "Are kids getting enough physical activities these days?" ask, "What percentage of kids achieve the recommended 60 minutes of physical activity at least 5 days a week?" That question is much more specific and can give you more useful information. Now, let's talk about measurable questions. Measurable questions can be quantified and assessed. An example of an unmeasurable question would be, "Why did our recent video go viral?" Instead, you could ask, "How many times was our video shared on social channels the first week it was posted?" That question is measurable because it lets us count the shares and arrive at a concrete number. Okay, now we've come to action-oriented questions. Action-oriented questions encourage change. You might remember that problem solving is about seeing the current state and figuring out how to transform it into the ideal future state. Well, action-oriented questions help you get there. So, rather than asking, "How can we get customers to recycle our product packaging?" you could ask, "What design features will make our packaging easier to recycle?" This brings you answers you can act on. All right, let's move on to relevant questions. Relevant questions matter, are important, and have significance to the problem you're trying to solve. Let's say you're working on a problem related to a threatened species of frog, and you asked, "Why does it matter that Pine Barrens tree frogs started disappearing?" This is an irrelevant question because the answer won't help us find a way to prevent these frogs from going extinct. A more relevant question would be, what environmental factors changed in Durham, North Carolina between 1983 and 2004 that could cause Pine Barrens tree frogs to disappear from the Sandhills region? This question would give us answers we can use to help solve our problem. That's also a great example for our final point, time-bound questions. Time-bound questions specify the time to be studied. The time period we want to study is 1983 to 2004. This limits the range of possibilities and enables the data analyst to focus on relevant data.